xy. Okay. dyz and dzx dx square minus y square and dz square orbital. Okay. If it is x and y, dxy, y and dz, dyz, z and dx, dxz, is the x-axis, y-axis means dx square minus y square, and this is z-axis means dz square. This is the shape of orbital, but this shape of orbital cover to me also. Okay, this shape of orbital you should not distinguish before approach the ligand because all are same energy. You should not identify which one is a dxy, dyz, dzx. So that is the beauty of CFT. Okay, that is the beauty of CFT. That is a look at here. So first d orbital. So here all 5 d orbital have same energy. That state we can call as a degeneracy. Degeneracy means all the d orbital have same energy. So this is, I told you, while approach the ligand. This is after approach the ligand. So how much the energy difference will be there? How much lower, how much higher means that is from the center point minus 0.4 and from middle to top plus 0.6. They given del naught, the x and y, whatever it is. The first one, middle one is a del naught. Okay. So here the first one 5 orbital d orbitals have same energy. Okay, same energy. That is called degeneracy. Okay. Degeneracy. If you want the notes, you can write it one by one, the point by point. So what happened? In octahedral complex, if you want the write up means to write the point by point. In octahedral complexes, the metal ion in octahedral complex, the metal ion present at the center of the complex, the metal ion present at the center of the complex, and the ligands occupy the 6 corners of octahedral. Ligands occupied the 6 corners of octahedral complexes. Ligands occupy 6 corners of octahedral complexes. Okay, right. So this is the octahedral geometry. The metal atom or ion present at the center of the complexes, and the ligands occupied 6 corners of your octahedral geometry. So which means here L. So from top and bottom ligand 6 corners. Okay, 6 corners of octahedral complexes. So here okay. So here this is a D2G orbital, this is a EG orbital, So don't worry about this T2G, and the G means gerade point. Okay, in tetrahedral complexes you should not mention the G, right? Because that is not a gerade. That is a group theory, separate chemistry. Forget about it. Only you remember T2G and EG. Okay. So right, T2G means what are the orbital is there. This is no separation of d orbital. Here 3 orbitals are there. Right. Here 2 orbitals are there. One is there dxy, dyz, dzx, and here dx square minus y square and dz square orbital. So from the center point, this is minus 0.4. From here plus 0.6. This is a del naught. Okay. Why the T2 orbital is a lower energy? Now only the geometry of the orbital is come for your discussion. So think about it. You know that dxy orbital. I am explaining only one. So this is a x and y means the orbital is there like this. Okay, orbital is like this. Similarly, the other area dx square minus y square, the orbitals are like this. This is a x and y means this one dx square minus y square. So take it these two orbitals. This is a higher energy, this is a lower energy. So here the lobes of the orbital in your d orbital dxy, yz, zx, the lobes of the orbital present in between the axis. But here the lobes of the orbital present along the axis. When the ligand share the electrons through the along the axis means, they think about it. If the ligand approach towards the axis side means, look at it here. I told you this is a more electron cloud. In the ligand also more electron. So head-on overlap. Head-on overlap is a repulsion force, because here also electron, here also electron. How the electron is occupied to the central metal atom? No, it repels. So therefore, these electrons share in between the orbital of your metal orbital. That's why this is a lower energy. Okay, I told you the guest will come to your home means, you know, 10 member of guests will come. Preferably you occupy the rooms, you share the rooms, you allocate the room that guest. So this is a best room with the AC. So this is our very close guest. So non-AC room, this is a different guest. So like that, metal orbital also easy to allocate the electron or else allot the electron in the lower energy. Therefore, which one is the lower energy means pxy orbital, yz orbital, zx orbital. Because of here the orbital lobes present in between the axis. So ligand easy to share the electron. Ligands easy to share the electron. Here it is not share the electron because of head-on overlap. That is repulsion only. Negative, how negative bond will be there? No, it repel. Plus minus attraction is there, but minus no. It is a repulsive force. Because of that repulsive force, immediately the ligand electron share to the T2G orbital. Okay, here how many number of orbital is there in between the axis means 3 orbital dxy, yz, zx. Therefore, that 3 orbital comes to the lower energy. Along the axis, how many orbital is there? 2 orbital dx square minus y square, and similarly dz square orbital also is present along the axis. Therefore, this is a higher energy. That means it won't share along the axis. Anyhow, if it is filled all the electron in the T2G, there is no other way. We have to fill the electron in the EG orbital only. Okay. So that is a concept. Why lower energy? Why higher energy? Any doubts?
So can you repeat the higher energy and lower energy part, like the along the axis?
Yeah. So think about it. You know this is the geometry of the octahedral, right? Geometry of the octahedral. So the axis present there means the ligand is not share the electron with the dx square minus y square dz square orbital because of the lobes are present along the axis, towards the axis side. So
Like
ligand also share the electron towards the axis side, means it repels, minus force is there. So it repels to each other, that's why immediately these electrons share with the T2G orbital, because of here repulsion is less compared to this one. Here repulsion is more. This is also del minus, this is also del minus. But here del minus, del plus. Okay, del plus. Therefore electron is okay. Central metal atom, either ligands or negative ion, it share the electron with the central metal atom. Okay, that is a concept. Now you write it. Why the T2G orbital is a lower energy? That point you can write it. So after this explanation, that means you draw the diagram. Okay, you draw the diagram. Everything you remember, because of calculation. Definitely they will ask from the CFSE. Write it now. In octahedral complexes, write it. In octahedral complexes, the d orbital split into T2G and EG level. The d orbital split into T2G and EG level. The d orbital split into T2G and EG level. Here T2G orbital is a lower energy. Here T2G orbital is a lower energy. Because of the lobes are present in between the axis. Because the lobes are present because of the lobes. You know that orbital lobes. The lobes are present in between the axis. And hence the ligand orbital share the electron, and hence the ligand electron, or else the ligand share the electron preferably to the EG orbitals. The ligand share the electron preferably to the T2G orbitals. Next point. And EG orbital, the same octahedral complex, the EG orbitals are higher energy. The EG orbitals are higher energy because the lobes are present along the axis. The lobes are present along the axis. Because the lobes are present along the axis, therefore the ligand and metal orbitals, follow the head-on overlap. Okay, follow the head-on overlap. Okay, follow the head-on overlap. Hence, the EG orbitals are higher energy. Okay, right. You know what is a head-on overlap, side-on overlap. Okay, this is a head-on overlap, always higher energy only. Okay, you know the energy diagram. If it is lower energy, higher energy means first electron will here, next one will here. Okay, this is a head-on overlap with the central metal atom with your ligand. That is not preferable. Okay, the electron first. But here, side-on overlap. That's why I given here the ligand or metal orbital like this means the ligand orbital like this. Therefore, these electrons will share with the central metal atom. So this is a head-on overlap. So now, if the geometry want to stabilize this P2G and EG orbital, right? Otherwise, it go to the original state. Like the magnet, if you keep the magnet here, that time the magnetized particle comes straight, the same direction. If you lose, again it comes to the original side. So similarly, if you want to stabilize this geometry means it needs some energy. That energy is called crystal field stabilization energy. So what is a CFSE? Crystal field occupied in T2G level plus 0.6 Y. That is how many number of electron in the EG level plus MP or else del naught plus MP. Okay, plus MP. This is a formula. So CFSE equal to, that means what? So this much energy it's required or else it needs to stabilize that geometry of the structure. Otherwise it comes to the original state. Okay, so CFSE equal to minus 0.4x plus 0.6y into del naught plus MP. The del naught indicates the octahedral splitting. Del T means tetrahedral splitting. Okay, MP means the pairing energy. Yesterday only we discussed what is the relationship between del naught and P. Crystal field splitting energy with the pairing energy. What is difference between splitting energy and pairing energy? If it is greater than or less than, what happens? We discussed yesterday, right? Right. So here exists the number of electron in T2G level, and Y is the number of electron in EG level. Okay, EG level. M is the, and what is P? P is the pairing energy. M is the how many number of paired set of electron. Okay, how many number of paired set of electron. When we come for the discussion, that time I will explain very clearly what is a paired set of electron. Okay. You got it? That's what number of paired set of electron. For example, if it is D4 complex 1, 2, 3, 4, this is M. How many number of paired set of electron? Okay, that is M. That's why when you come for the calculation, that time you know what is M. M means number of paired set of electron. Okay, P is the pairing energy. That means the fourth electron. I told you yesterday, if the D4 complex weak ligand means 1, 2, 3, the fourth electron. The fourth electron forced to occupy in the T2G level, how much energy it needs to force to the ground state itself. That energy is called P, pairing energy. Okay, splitting energy means if the d orbital is there, it want to split in the d orbital from d level degeneracy state to non-degeneracy state. How much energy is required? That is del naught. Okay, del naught. So CFSE equal to minus 0.4x. You remember this formula, based on that they ask the calculation. Definitely one question will come. Maybe we will work out. Any doubt here? So this much point you have to write it in asking the d-orbital splitting of octahedral complex. That means you write the d-orbital structure you write the octahedral splitting of d orbital degeneracy state to non-degeneracy state. What is the hypothetical situation between degeneracy with a non-degeneracy state? That is a hypothetical situation, right? This is a hypothetical situation. Okay, that is temporary. This is a permanent, this is a permanent, but this is temporary. That is hypothetical situation when the crystal field degenerates. Okay, when it happened when the approach the ligand, to the central metal atom, the degeneracy, all the points you include, when approach the central ligand to the central metal atom, the degeneracy state, it becomes non-degeneracy state. So that time the d orbital split into two energy levels, T2G and Eg levels, with the energy separation of minus 0.4x plus 0.61. So this much explanation you give, right? That we discussed what is pairing energy, what is spectrochemical series, everything yesterday over, right? So d orbital splitting of octahedral over. Similarly, we can go for the tetrahedral complex also. Before that, we discuss some calculation. Time? Then more than 10 minutes. Okay. Some calculation. Okay. Yeah, so they given some information. Calculate a CFSE value for Gopal Hexa Aqua 2 plus complex. Their CFSE value they given 7360 centimeter inverse. What is the CFSE? CFSE means crystal field stabilization energy. Energy they given in terms of centimeter inverse. They ask the result kilojoule per mole. That's it. They given the information CFSE. You know the formula, CFSE formula. What is the CFSE formula? Minus 0.4x plus 0.6y into del naught. Okay, into del naught. So they ask what is a del naught in terms of kilojoule per mole. That's it. Very simple. So they given CFSE, therefore you substitute 7,600 and 600, right? Yeah, 7,360, yes, centimeter inverse equal to. So if you want to know the X and Y means, you must know about the splitting of d orbital. So here you can do it, the splitting of d orbital. So what is the Gopal atomic number? Atomic number of Gopal. Atomic number of Gopal. We know that D class element, D1 series. Scandium, titanium, vanadium, chromium, manganese, iron, Gopal, nickel, copper, zinc. 27. See. SCTA, VCr, Mn, Fe, CO, Ni, Cu, Zn. SCTA, VCr, Mn, Fe, CO, Ni, Cu, Zn. So that is a first D block series. So here it starts from the 1, that is D1. D1, 2, 3, 4, 5, 6, 7, D7 complex. So D7. Here 2 plus oxidation state. For your understanding, you know how to calculate the D block element, right? What is the configuration? CO means, what is that? 4s2, 3d7. Am I right? You forget about the argon, that is internal configuration. You ignore it. Okay. So if they given, what is the number? This is the neutral ligand. Therefore, these 2 plus charge is directly come to your CO, Coorindation complex. This one. Therefore, CO2 plus means you remove 2 electrons from the s orbital because that is outermost orbital. Therefore, 3d7 complex. So 3d7. So 3d7 configuration. Now you find it. How many number of electrons? D7. If it is 3 plus complex means what is the number of d electron? If it is 3 plus complex means what is the number of d electron?
6.
You tell me.
6.
6. D6. Okay. D6. Right. Now you fill the electron. 1, 2, 3, 4, 5, 6, 7. Okay, 7. Assume this ligand is the weak ligand. If they didn't mention any weak or strong ligand means you calculate both. You calculate both. Right? What is it now? So here how many number of electron is there? In T2G level. 5 electron. Therefore, minus 0.4 into 5 plus 0.6 into how many number of y electron? 2 into del naught. So you can ignore the plus MP plus MT. Listen, you ignore the plus MP because when they given the pairing energy means it is applicable to include. If they didn't given any pairing energy or else number of sets of paired electron means you ignore it. You can use it up to del naught formula. Keep it in your mind. They given pairing energy means plus 1.2 del naught. So therefore, if you calculate how much? 0.8 del naught. MP. When you consider the MP means if they mention any pairing energy is 12,000 centimeter inverse, calculate the CFSE value means that time you include plus MP. Otherwise, no need for that MP. Right? So how much you got it? Minus 0.8 del naught. Katapa. So now only the conversion is there. Any of you remember the conversion? Sometimes they given the conversion in the question itself. Otherwise, we can do it. So that means 1 kilojoule per mole equal to 84 centimeter inverse. Okay, 84 centimeter inverse. Therefore, 1 centimeter inverse equal to what? 1 by 84 kilojoule per mole. 1 centimeter inverse equal to 1 by 84 kilojoule per mole. So therefore, you convert it, okay, you convert it, this much centimeter inverse equal to how much kilojoule per mole divided by 0.8. This minus indicates what? This much lower energy. That is, sign indicates lower or higher. This is not a physical chemistry calculation. You can use the same minus and plus. That indicates that much energy is lower. That's it. Okay. You know that lower. If the scale is there means 0 to 15 centimeter inverse, 0 to minus 15 centimeter inverse. That is a direction case. Left hand side, like right hand side for our purpose. So therefore, what is it? Minus 7,000 360 into 1 by 84 kilojoule per mole. Okay, this 0.8 divide, it will come denominator. 0.8 equal to del naught. Am I right? So at finally what you get it, that del naught equal to what? How much you got it?
109.
Yeah, approximately 110. 110 kilojoule per mole. That's what minus plus indicates lower or higher. Yeah. You understood, right? How much energy lower or how much energy higher? That is a sign indicates here. Thank you, Papa. Okay, is it fine? So here you must know either this is a strong ligand or weak ligand. Definitely you must know. Otherwise you don't know that how much electron in T2G, how much electron in the EG. That's the information. Then what is it? Number of d electrons. Sometimes they didn't given the number of d electrons. They given only the complexes like CO, H2O 6 times, 2 plus complex, 3 plus complex. You only calculate how many number of d electrons. Okay, you can do it, the practice. And similarly, the ligand, the spectrochemical series, you remember. If they didn't mention that is a weak or strong ligand, means you calculate both weak and strong ligand. Okay, sometimes they didn't given the weak or strong ligand. You identify in the MCQ question like that will come. They didn't mention strong or weak ligand. You only know. Otherwise, you do it both weak and strong ligand. What is the CFSE? Immediately you pick the option. Right? Anything doubt?